And lastly, we come to image formation using lenses. Lenses, in particular thin lenses. Thin lenses are optical devices that refract light. Therefore, any images formed are formed using refracted light. The same equation is used for lenses. 1 over s plus 1 over s prime is equal to 1 over f is equal to 2 over r. S is still the object distance, S prime is still the image distance, F is still the focal length, location of the focal point, and R is still the radius of curvature. And the focal length F is still equal to R over 2. But this time, because we are talking about refraction instead of reflection, the sign convention for our variables is slightly different. So please take note of the differences in the sign convention. First, we look at object distance S. Object distance S is positive if the object is in front of the lens and negative if the object is behind the lens. S prime, image distance. S prime is positive if the image formed is behind the lens, and the image is called a real image. It stands to reason that the real image will be behind the lens because the image is formed by refracted light, and refracted light for lenses is always behind the lens, behind the refracting surface. So S prime is positive if the image is behind the lens, and negative if the image is formed in front of the lens, and the image is called the virtual image. So S prime positive, you have real image. S prime negative, you have virtual image. Next up, we have the focal length F. F is positive if the focal point is behind the lens, and F is negative if the focal point is in front of the lens. Now, if you look at the image or figure provided, you see the lens. There are two capital F, F1 and F2. That's because for lenses, you have two focal points. F1 is the primary focal point, and F2 is the secondary focal point. Focal length F is referring to the location of the secondary focal point, capital F2. If F is positive, F2 is located behind the lens. And if F is negative, F2 is located in front of the lens. Next, we have the radius of curvature R. R is positive if the radius of curvature is behind the lens, and if negative if the radius of curvature is in front of the lens. Now we're talking about the actual refracting surface. R is positive if the radius of curvature of the refracting surface is behind the lens, and negative if the radius of curvature of the refracting surface is in front of the lens. There are two types of lenses. You have converging lens and diverging lens. Converging lens, sometimes referred to as convex lens, the radius of curvature and the focal length are both positive. Again, for converging lens, R and F are both positive. And for a diverging lens or concave lens, both the radius of curvature and the focal length are negative. Again, for a diverging lens, R and F are both negative. As you can see, the location of F2, the secondary focal point, is in front of the lens. Therefore, F is negative. Please consider as reading assignment the following. Lens maker equation. It's an equation that will allow you to determine the focal length of the lens from the dimensions of the lens itself. And that's pretty much it for our discussion on optics. Thank you for watching.